Okay, excellent. So, hello everyone, I'm Tamara and I'm from Air Navigation Systems Department of the Now University. Today I would like to present the results of our work on the topic of airplane trajectory analysis for round-trip flights with ADS-B data. So, to ensure flight safety, all aircraft must use a network of flight routes. If everyone will use pre-planned flight route, we can guarantee the safety of air transportation. Flight routes network consists of nodes and linear road intervals. Planned airplane trajectory is represented as a sequence of waypoints by which flight could be realized. There are flight plans. To fly in airspace, a pilot must develop a flight plan. Different criteria of effectiveness could be used for flight plan trajectory selection. Minimum cost, full amount required to perform a flight, and the shortest flight time. Below is one of the road plans with waypoints, and roads, lines. There are flight various software is used to assist the flight in creating a flight plan. This slide shows the results of planning a flight plan in SkyVector software. This is an example of a planned flight path with the trajectory of the airplane in the mass lab shown at the bottom. So it is mass lab and it is in SkyVector. After the pilot has filled in the route, he submits it to the Aviation Administration, and after the plan is approved, he programs it into the FMS. Here is an example of such a route with intermediate points such as OR, PNH, HRV, SRO, and etc. So it is waypoints and it is this FMS. The implementation of the project flight plan depends on the state of the atmosphere and especially on the wind strength and direction. Here is the weather, namely the wind map of August 24th, 2023. The color is the wind speed in kilometers per hour, and there are pointers, and they shows us the direction of the wind. Wind could be represented as a vector quantity as it has a direction. A headwind during the horizontal flight on the flight level slows down the ground speed of an aircraft, while a tailwind accelerates the movement of an aircraft, so the ground speed increases. Even crosswinds, such as those blowing at 90 degrees to the direction of the aircraft, will also affect the aircraft. Such a crosswind will move the plane in the direction in which it is blows. As an example of weather impact on flight planning, this slide represents trajectory variations for round-trip flight AAR 169-170 of connection between Los Angeles and Tokyo international airports. It represents 30 trajectories for June 2023 in conical cartographic projections. Also, you can see this black line, and this black line is shorter in arc. Pilots have to fly along it, but because of the wind, they can adjust their route up to 500 kilometers, maybe more or maybe less. In our study, we would like to provide an analytical study of performance of an efficient flight planning process. We provide statistical analysis of round-trip flights based on actual airplane trajectory data shared by ADS-B data. In statistical analysis, we consider following parameters: edge length calculated as an arc length of a great circle, distance between 2 points in Euclidean space, and total flight time. We use the following formula for total trajectory length of our airplane based on arc length of great circle. Due to the action of multiply factors in parameters value, a kernel probability density function (KPDF) could be used for parameter distribution studies. The following form of non-parametric function of KPDF could be used. This form. Due to the action of multiply factors in parameters value, a kernel probability density function could be used. We use raw trajectory data of AAR 169 and 170 flight of connection between Los Angeles to Tokyo International Airport. Dataset includes 91 historical flights from April 17th to July 18th, 2023. In statistical analysis, we use KPDF with compression to normal PDF and PDF. Obtained results indicate about 1 hour 10 minutes difference between direct and back or opposite flights. The first bar graph shows the total time in both directions, and the second graph shows us distance in one and the opposite direction. The same statistical analysis has been provided for the following flight connections. Here you can see the results of this analysis for flights in mean flight time and mean trajectory length for direct and opposite flights. So we can see flight numbers, yes. So for example, AAR 169, it is a direct flight, and 170, it is opposite flight. So it is from airport Los Angeles to Tokyo and to Tokyo Airport, and this is from Tokyo Airport to Los Angeles Airport. There are unique codes for each airport. So it is code for Los Angeles Airport, and this is code for Tokyo, and etc., etc., etc. There are different airports. Airplane model and size of data. There we can see result of mean total flight time and total flight length for direct and opposite flights. Yes, it is flight number that I said, and direct time and opposite mean time, trajectory length, mean, direct and opposite. As we can see, there is no very big difference, about 3 minutes or minute, and in length it is about maybe 100 kilometers or less, or a little more. So it is not very big difference. Yes, and here you can see conclusions of our work. Do you have any questions?
Okay, thank you for your report, dear participants. Do you have any questions? Okay, I have questions. Tell us, please, this analysis can be done only after the flight, or can it be used for prediction trajectory of possible flight, for example, today?
Oh, okay. No, I think that after flight, because we didn't have any maybe information about time of. Okay, we have information about time, but we don't know how our plane, how much time it will fly. So I think that no.
And weather we cannot to predict. Yes.
Yes.
Okay, thank you very much. Dear participants, any other questions? Okay, thank you.